Problem number 8. A bookmark maker sells bookmarks for either for $1 each, or if you buy more, you save more. You can buy 7 for $6. The question is, in order to save more money, how should you arrange the package so that you pay the least if you want to buy 2017 bookmarks? Obviously, in order to do that, you should try to buy 7s, as many as you can, right? Because that helps you save money. Okay, so what you should have, clearly, you should buy the 7 package as many as we can, right? This is clear. Should buy, sorry, should put this buy here. Should buy 7 package as many as we can. Okay, so let's see how should I arrange 7 package. So what we do is we just do the division. I try to divide 2014 into 7777, right? Let's see how far we can go. So I divide this one by 7, 2, 14, 61, 6. This is 8 again, 1. All right, so we got the remaining is 1. So that means we can go the package 288. We can have 288 package of 777, and then the last one we have to just buy it individually, right? So then we get the total cost. The total cost is 288 and multiplied by 6, because for 7 package is $6. So times 6, and then plus this extra 1. Let's calculate. So 288 multiplied by 6, right? Okay, so that's what we have. 4, 5, 7. Okay, so this one is 1728 and plus 1. So finally, we get the answer is $1,729. Problem number 9. The problem says here we have a big triangle. The triangle is divided. So first of all, we have a triangle. It's divided into equilateral triangles. So here we have different kinds of equilateral triangles, different kinds in the sense they have different side length. And we know the smallest one, which is the shaded one, the side length is 1. The question is, what is the parameter of this big triangle? Now, in fact, this big triangle is also equilateral triangle. This is not explicitly given. It can be derived from this geometric picture. Let's do it. Okay, so here we have this is 1, right? And this is 1, because everything is equilateral. So this is 1, this is 1, this has to be 1, this is 1. So this is 1, this is 1. All right, so we got this is 2, this is 2, this is 2. So here's 2, here's 2, here's 2. So we got this one is also 2. Okay, now, and this is 1. All right, because all these are the same, so they are all equilateral triangles. So we have those left yellow. So here we have those yellow line segments. They are all the same. Because here, so these 2 are also the same. Well, if you add together, so this 2 equals, this one should be 1 plus 2 and divided by 2. So that's 1.5, right? It's 1.5. Okay, so for the yellow piece, it should be 1.5, 1.5, 1.5, 1.5. So if we calculate the side length, so this side length, this one is 1 plus 2 plus 2, that's 5, right? If I calculate this part, that's 1 plus 1 plus 1.5 plus 1.5. This is also 5, right? Now we calculate the other side. So this is 1.5 plus 1.5 plus 2. This is, again, is 5. So this is what I mean. Although it's not explicitly given, this big triangle is equilateral. But after calculation, we find it is indeed equilateral triangle. Then we have the parameter. The parameter equals 5 multiplied by 3, that's 15. Problem number 10. How many different 3-digit numbers consist of 3 distinct digits from 0, 1, 2, 9, 5 and are divisible by 2, 3, 5? All right, so here we are looking for 3-digit number. Each digits are from these 5 digits. And also the requirement is the number is divisible by 2, 3, 5. All right, so let's look at 2 and 5 first. So we know for a number to be divisible by 5, the last digit has to be either 0 or 5, right? So we say, okay, so the last digit has to be either 0 or 5 to be divisible by 5. But nevertheless, because it also required to be divisible by 2, that means it's even number. In order for even number, we must have the last digit is 0. So combined the two, we must have the last digit is 0. Now, you can also see this from another perspective, because in order to be divisible by 5 and 2 and 5 implies it's divisible. It is divisible by 10, right? Now, if it's divisible by 10, then of course the last digit has to be 10. Has to be 0. Okay, now we need to decide the other 2 digits, and then we need to utilize the condition is divisible by 3. So let's recall the divisibility test for 3. So divisibility test for 3. So we know a number is divisible by 3 if and only if the sum of digits is divisible by 3. So the sum of digits is divisible by 3, right? So we need, so by this, we need these 2 and together is divisible by 3. Okay, and also we need the digits to be from, because 0 is gone. So we need to choose from 1, 2, and 9, and 5. Now, in order to divisible by 3, we have 2 different combinations. Well, either it's 1 plus 5, right? Or is 1 plus 2, okay? And also we can switch the order, and then in total we get, either we have it's 5, 1, 1, 5, or we have is 1, 2, 2, 1. So put together, in total we have 4 different such 3-digit numbers. Okay, so here the main point is we need to use divisibility test. So first for 2 and 5, right? So it has to be 2, it has to be even, 5, the last digit has to be 0 and 5, or as I said, a shortcut is if divisible by both 2 and 5, it has to be divisible by 10, therefore the last digit has to be 10. And 3 is sum of digits has to be divisible by 3. Problem number 11. Here we have 2 teams, team A and team B. So altogether, if we combine all people together, the average score is 18 in the AMC 8 test. For team A, we know team A has 20 students and the average score is 14. We also know the average score of students in team B is 23. So the question is how many students we have in team B. So here should be team B. The most convenient way to solve this problem is to use algebra. So we are going to introduce a variable. We say, okay, we denote X as the number of students in team B. So we have, let's denote X as number of students in team B. So what we need to do is we need to set up the equation. So how are we going to set up the equation? So we're going to set up the equation based on the total score of team A and team B put together. So then we have the total score of A and B equals, because the average is 18, right? So it's 18 times the total number of kids in team and team B. Team A, we know it has 20 students, so it's 20, and plus this 20 plus this X, right? 20 plus X. Okay, so then we know the total score can also separate into 2 parts. One part is in A and in B. So A, the total score in A is 20, so it's 20 times 14. That's because we know that A has 20 students and the average is 14. So this is total score of A. And then we look at the total score of B. Now B, we know the average. So what's the average? The average of B is 23, right? So okay, so 23 is 23, and then multiply by the number of students in B, so that which is X, so which write as 23X. As we said before, if the multiplication involves letters, usually we omit the multiplication sign. Okay, so then they add together equals to this one. Let me set the equation. So from here we derive the equation is 18 times 20 plus X equals 20 times 14 and plus 23X. Okay, now this one, let's write out. So this multiply this and multiply by that. Okay, so 18 multiplied by 20, so we get 360 plus 18X equals 20 times 14. This one is 280, right? So it's 280 plus 23X, right? 23X. Okay, so then we move the 18X to the right-hand side, so the minus 18. And we move the 280 to the left-hand side. And finally, it's reduced to 80 equals 5X. And then we get X is 16. X is 16. So we get the number of students in class B is 16. Okay, so here we use the algebra. We set up a variable, we introduce a variable, and we set up equation. We can solve it very quickly. Problem number 12. So the following figure has 5 squares outside the length 2, and they put in a symmetrical way. What we need to figure out is what fraction of the area is this shaded triangle. Okay, so the fraction, according to the general formula, fraction equals the area of the shaded region divided by the total area. Right? Now, total area is clear. Each triangle, each square has area 4. You have 5, right? So this one is just 5 times 4, which is 20. So this one clear. What we need to figure out is the area of the shaded region. Okay, so we need to figure out, so the goal, the area of the shaded region. Okay, so how should we do that? It's a triangle. Triangle, usually what we do is we say, okay, we have height multiplied by the base and divide by 2, right? But this is not in a grid shape. For this kind of situation, the typical way to do is use cut and paste. So use cut and paste, cut or paste, right? Or cut and paste. Now for this one, I'm going to use the paste. So what I do is I put this back to form a big rectangle. So let me mark all those sides here. So I have, this is 2, this is 2, this is 1, this is 2, 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 this is 1, this is 2, this is 2. So by the way, so here I put the side length of 2. This is just for convenience. It's not really needed. Okay. So in general, you can put any number and you get the same answer. Or if you like algebra, you can just put, let's say, A or any letter, and then you have cancellation. You get the same thing. Okay, so here we just use 2 as convenience. So now let's calculate the areas. The area of this one, this will just be 2, and the area of this, this is also 2, right? This is right triangle 2, 2, and let's calculate this part. So I can divide into 2 parts, and this is 2. All right, so here I have this is what? This is 5. So 5 times 2 divided, so the whole, this one will be just 5, right? Okay, and here I have this side, this is 3. This is what? This is 4. So 3 times 4 divided by 2. So I have this part is 6, right? That's 6. Okay, so I get the area. The area of the shaded region is the bigger one. So it's the bigger one. So the bigger rectangle minus those outside parts. So I minus 2 plus 2 plus 2 plus 5 plus 6. Let's calculate this. Okay, so the bigger rectangle is 4 times 6 So that's 24, right? So it's 24 minus, here we have, this is 6, this is 11, right? So that's it's minus 17, right? Minus 17. So what we have is, we get is 7. All right. So we derive the area of the shaded region is 7. So we put the 7, right? So put back into the general formula. So 7 over 20. So the answer of the fraction equals 7 over 20. So here the main point is we apply the cut and or paste. So here I use paste to calculate the area of the shaded triangle. Problem number 13. Here we look at a special class of numbers called palindromes. So palindromes are numbers that are symmetric with respect to center. So if you read from the left, it's the same as you read from the right. Okay, so here we are looking at those kind of numbers with digits 2, 2, 3, 3, 5, 5, 5, right? For example, 2, 3, 5, 5, 5, 2, 3, 2. The question, how many such numbers do we have? All right. Here, the key point is, because we have 3, 5, right, all the others are pairs. Therefore, in order to perform such a symmetric number, the 5, 1, 5 has to be in the middle. So that's the key. So key point is 1, 5 has to be in the middle. So 1, 5 has to be in the middle. Okay, if I have this 7-digit number, 5 has to be in the middle. And then all we need to do is the other numbers, we have 2 more 5, we have 2, 2, and 2, 3. They have to on left-hand side and right-hand side. So in other words, what we should have is 2, 3, 5 on one side, and the other 2, 3, 5, 2, 3, 5 on the other side. And then you just do the symmetry, right? So if I do 2, 3, 5, then I should have 5, 3, 2. If I do say 2, 5, 3, then this here I just have 3, 5, and 2, right? So if I decide the position, so all I need to do is I need to decide the positions on the right-hand side. So this is equivalent. So the problem is reduced to find permutation of 2, 3, 5, right? Okay, so we know if you have 3 numbers, or we say 3 people, how many different ways we can arrange them? The number is 6. Either you can just get this manually count or use the multiplication principle. Let's recall that. So if I have 3 places, the first one I use the multiplication principle, right? Okay, so I have the 3 choice for the first one, where I can do 3, 4, 5. Then I have the 2 choice for the second one. And then I have 1 choice because whatever is left is put the third one. So if I put together, I have 6 different ways to arrange 3 numbers or 3 people, right? Okay, so the answer is 6. Problem number 14. We have a standard 6-sided die and it's rolled 3 times. And we are looking for the probability that 3 numbers we get, right? If you roll once, you get 1 number. Twice, you have 2 numbers. 3 times, you have 3 numbers. So here we're looking for the probability that either these 3 numbers, they're all different or they're all the same. Okay. All right, so first of all, let's recall. A standard die means it has 6 numbers, 1, 2, 3, 4, 5, 6, and each number on one face, right? All right, so let's recall the general formula to calculate probability, as we have mentioned numerous times. It's a fraction. The denominator is the number of total cases. The numerator is the number of those valid cases. So valid cases depends on what you want. For here, what we want is they're all the same or they're all different. So those are valid cases. All right. Now the number of total cases, that this is what we have. It's just 6 times 6 times 6, right? It's just by the multiplication principle. So what we have is 256. 16. Since for each time you have 6 possibilities, you have second time you have 6 possibilities, and third time you have 6 possibilities, you by multiplication principle, just multiply together. Right? So here we just use this, again, is our favorite multiplication principle, all right? Okay, now we need to calculate the valid cases. Valid case means either they're all the same or they're all different. We'll do 2 situations. So one, they're all different. Right? Okay, so if they're all different, we roll 3 times. The first one we have 6 choices. Again, we use our multiplication principle. For the first time, we have 6 possibilities. And the second time we have only 5. That's because we want to be different. The third time also it's going to be 4 because we have 2 numbers. The third one needs to be different from the previous 2. So that's we apply the multiplication principle. All different, that's all we have. And this is 120 different scenarios. And then the second situation is they're all the same. Well, this one is simple, right? We just have 6 possibilities. Either they're all 3, all 1, all 2, all 3, all 4, all 6. Right, so we have 6 possibilities. Now we just add them together, right? So we say, okay, you add them together, you add these 2 together, so it's 126. Okay, so we get for the valid case, this one is 126. Okay, so the probability equals 126 divided by 216. Now we need to simplify this. Obviously, we can simplify because both of them are even numbers. At least you can divide by 2. And then you can see, you can also divide by 6. Let's do it. So we can simplify this. First, let's divide by 6, right? The first one is what? Is 21. And the second one we just did is 26. Now then we can further, we say, okay, I can still divide by 3, right? Divide by 3. Then this one is 7, and this is 12. Okay, good. 7 over 12, that's the simplest one. We cannot reduce any further. Therefore, the answer is 7 over 12.